Good morning, one and all. Today, we are going to solve a very different problem that we have never solved. Like you have never solved this kind of problem because here you have seen uh, lambdas, like lambda one, lambda two, lambda three, lambda four, and all. Four types of lambda is given. So here now we are going to solve a different problem. Take note this problem. The incremental fuel cost in dollar per megawatt hour for 4 units of a plant are lambda 1 is equal to df1 divided by dpg1 is equal to 0.012 pg1 plus 9.0. Next, lambda 2 is equal to df2 divided by dpg2 is equal to 0.0096 pg2 plus 6.0. Next, lambda 3 is equal to df3 divided by dpg3 is equal to 0.008 pg3 plus 8.0. Next, lambda 4 is equal to df4 divided by dpg4 is equal to 0.0068 pg4 plus 10.0. What they have given is if all 4 units operate to meet out the total plant load of 800 megawatt, find the incremental fuel cost lambda, find the incremental fuel cost lambda of the plant and the required output of each unit for economic dispatch. Like that they have given in this problem. So whatever the problems that we have solved, almost 30 problems we solved in the previous classes. If you just go back to my videos and you have seen, the 30 problems only we are calculating only one lambda. Now there are four lambdas are there, four different lambdas are there. What they asked to do is they asked to calculate find the incremental fuel cost lambda. So this is the different problem. As I said before, so whatever say, for example, it is so general fuel cost function, it is of PGI squared plus BI PGI plus CA. That is the general formula. But here lambda they have given. So what we have taken is this coefficient we have taken as alpha 1. This coefficient we have taken as beta 1. Like that we have taken. And this coefficient we have similarly this coefficient as alpha 2, beta 2, alpha 3, beta 3, alpha 4, beta 4. Because this is the differentiated fuel cost. This is the differentiate fuel cost coefficient. So previously, whatever the problem we have seen, that is in the actual fuel cost coefficient, that is AI, BI, and CA. But here, this is already differentiated with respect to PG1, PG2, PG3, and PG4. So we have taken this as alpha 1, beta 1, like that. So now we are going to solve this problem. How to calculate this alpha t? Alpha t is equal to 1 divided by alpha 1 plus 1 divided by alpha 2 plus 1 divided by alpha 3 plus 1 divided by alpha 4, the whole inverse. So what is alpha 1? So alpha 1 is nothing but, so this is the general format, how it will be like a general format is like incremental fuel cost of the plant is given by alpha is equal to alpha t into PG, not this is alpha, this is lambda. Lambda is equal to alpha t into PG. Sorry, this is wrong. This is lambda. Alpha t into PGT plus beta t. This is not B here, this is beta t. So alpha t into PGT plus beta t. So first you need to calculate alpha t and beta t. So here alpha t is what? Alpha t is given as solved by alpha t is equal to 1 divided by alpha 1 plus 1 divided by alpha 2 plus 1 divided by alpha 3 plus 1 divided by alpha 4, the whole inverse. So what is alpha 1? Alpha 1 already we marked. So same thing, you need to substitute alpha 1, alpha 2, alpha 3, and alpha 1. These coefficient, that is a differentiated coefficient, that is called alpha 1. So that alpha 1, alpha 2, alpha 3, we need to substitute whatever is given in the problem, the whole inverse. Take your scientific calculator, simplify it. You'll get the answer as 0.00 2176. That is, in the scientific calculator, you'll get the value as 2.176 into 10 to the power of minus 3. So simplifying, you'll get a 0.002176. Similarly, we need to find out the beta t. So what is the formula for finding out the beta t? Is nothing but alpha t into beta 1 divided by alpha 1 plus beta 2 divided by alpha 2 plus beta 3 divided by alpha 3 plus beta 4 divided by alpha 4. Just we need to submit alpha t already we calculated that you need to substitute over here. Beta 1 you know. So beta 1 is this coefficient, this constant coefficient does nothing but beta 1. So that we are going to substitute over here. Beta 1, beta 2, beta 3 and beta 4 and alpha 1, alpha 2, alpha 3 and alpha 4. Just we are substituting here. Simplifying, we are getting the answer as beta t as 8.368. You just tell in the comment whether you got the same answer or different answer or not. Next, PGT is given in the problem as 800 megawatt. Well, if for all 4 units operate to meet the total plant load of 800 megawatt. So total plant load PGT is given as 800 megawatt. So what is the incremental fuel cost of the plant that is given as alpha is equal to, this is wrong, alpha is equal to alpha T into PGT plus beta T. Here it is not BT, here it is beta T. So whatever the alpha t we already calculated, that is here we calculated alpha t as 0.002176. The same thing we are going to substitute here and into PGT. PGT is 800 megawatt into 800 plus beta t. Beta t what? 8.368. So 8.368. Simplifying, we'll get the answer as a $10.1088 per megawatt hour. That is the lambda value we got. That is the incremental fuel cost of the plant. That is the lambda is $10.1088 per megawatt hour. Next, but with this lambda, we need to find out the economic dispatch of each unit by using the lambda iteration method. But lambda iteration method, what we have seen in the previous classes, we have solved many problems in our previous classes. Go through that problems also. Here, what is the lambda iteration method? How to find out the PGI is nothing but PGI is equal to lambda minus BI divided by 2AI. But here in this problem, the incremental fuel cost is given. That is 2AI is given. That is alpha I is nothing but 2AI. So therefore, this above equation is modified as PGI is equal to lambda minus beta I divided by alpha I, where alpha is nothing but 2AI, because in the problem itself, they have given us this is nothing but 2AI. Okay, so problem itself, they have given us 2AI, that is nothing but alpha I. So now the equation gets modified as PGI is equal to lambda minus beta I divided by alpha I. So just we need to find out the first generating unit, that is PG1. PG1 is equal to lambda minus beta 1 divided by alpha 1. So what is beta 1 that is given in the problem data? Beta 1, 9. Next, alpha 1, 0.012. Just we need to substitute over here. Here we need to substitute over here. We'll get to the PG1 as 92.4 megawatt. Similarly, PG2 is equal to lambda minus beta 2 divided by alpha 2. So lambda is what? 10.1088 minus beta 2. Beta 2 is nothing but 6 given in the problem divided by alpha 2. So just simplifying, we'll get the answer as 428 megawatt. Similarly, PG3 is nothing but lambda minus beta 3 divided by alpha 3. So lambda what? 10.1088 minus beta 3 given in the problem as 8 divided by alpha 3 given in the problem as 0.008. Simplifying, we are getting the answer as PG3 as 263.6 megawatt. Similarly, PG4 what? Lambda minus beta 4 divided by alpha 4. Lambda what? Given in the, we solved and we found it as 10.1088 minus beta 4 what? 10. Next, alpha 4 what? 0.006. 0.68. Simplifying, we'll get the answer as 16 megawatt. That is PG for us, 16 megawatt. Now, the generating units PG1, PG3 and PG1, PG2, PG3 and PG4 satisfies the plant load 800 megawatt. Just to be, if we add all this thing, so we are getting 800 megawatt. So this is the economic load dispatch values for this particular problem. But as I said before, different lambdas are given. So very easy. If this problem is asked in 5 marks or 10 marks, very, very easy. Like no need to, but this formula you need to because this is the derived formula. This formula you need to remember, that is alpha t is equal to 1 divided by alpha 1 plus 1 divided by alpha 2 plus 1 divided by alpha 3 plus 1 divided by alpha 4, the whole inverse. So that simplifying, we'll get the answer. Next, beta t is equal to alpha t into beta 1 divided by alpha 1 plus beta 2 divided by alpha 2 plus beta 3 divided by alpha 3 plus beta 4 divided by alpha 4. Next, what is lambda? How to incremental fuel cost lambda is equal to alpha t into PGT plus beta t. This is the formula for incremental fuel cost when lambda 1, lambda 2 and lambda 3 and lambda 4 is given. So this you need to remember. The rest are all same. And similarly here for calculating the economic load dispatch values with the lambda iteration method, PG1 is equal to lambda minus beta 1 divided by alpha 1. But in the actual formula is lambda minus bi divided by 2ai. Here 2ai will come, but 2ai directly given in the problem. So that's why we are directly taken as alpha 1. So that also you need to remember while solving this problem.